Hello everyone, how are you? This is Mohammed Tahir Ghazal from Bold Fun. This video, it will be another crash course tutorial video of how to build a Nostr client. In the last video, we saw how we can uh, create a basic Nostr feed, how we can filter by tags, how we can publish a node to the Nostr feed. And after the video, a few people asked us if we could cover more functionalities. So this is what I'll do in this video. We will continue from where we left off. And in this video, I'll cover mainly three parts. The first thing is how to support multiple ways of connecting a Nostr key. Like originally, we only saw how we can do if we have a Nostr extension, but we'll see if we have multiple ways. And the other thing, the other main thing is how to build a DM feature, encrypted direct messages, and like we'll see how to encrypt the messages, decrypt them, and fetch the messages from each of my contacts, etc. And finally, we'll cover a few problems that you might encounter along the way and how to solve them. And I think yes, that's it. So let's jump right into it. Now here is a project that for the people who did not watch the previous video, this is a React project bootstrapped with Vite. I will not be covering the styling or building the UI. My main focus will be on the Nostr logic and like uh, anything Nostr related, mainly to keep the video from being too long or boring unnecessarily. So let's first just run the project and see what we have. Okay. So this is the project that we have. This is the first new UI. We did not have this UI the last time. This UI asks you to connect your Nostr key using one of these methods, either using extension, generating a new key, or inputting your private key. So how this is done in code is basically so there are, as you saw, there are multiple ways to connect your wallet. I want to store whichever method the user chose in the local storage, so that in future times when he visit the application, I can just proceed with this way. So if he is using his Nostr extension, I want to just store the public key in the local storage. If he is using generated keys, then I want to store whatever private key he generated. If I want to allow the user to input his key, then I want to also store the private key that he inputted, and of course always the public key. Or the Nostr Connect, but the Nostr Connect is not fully supported yet. So here, these are the three buttons that you see in the UI. Whichever button the user clicks on, one of these functions will be called. If he clicks connect to Nostr extension, then I'll first check the window object to see if it has Nostr supported. If that's true, then I will ask the user to give me permission to his public key from his extension. If the user grants the permission, then I'll just return this object and store it in local storage. For other methods, like using connect inputted key, then I'll show a window prompt. Let's see. Like this is the simplest way to do it. The user will input his key here, private key here, and like the first thing I do is validate if it's a valid private key or not. If it is, then I decode it. Maybe the user inputted not a hexadecimal key, but like the private key in the NSEC format. So yes, I decode it to the hex format, store it, and finally, if he chose to generate a key, maybe he just want to use this website for one time, and he don't want to use his keys that are in his wallet, so he can just generate a key. We use the generate private key method that is exported from Nostr tools library. Okay, so this way we get the private key and or public key, and we know the method. Now this connection object, by connection object, like I'll use this term many times along in the video. By connection object, I mean the object which stores which connection method the user chose, the type, and the other fields, which are the public key uh, and the private key, but the private key might be missing. So this connection object, I'll need to use it in several places in the application. Whenever I want to sign an event, whenever I want to decrypt something, encrypt something, I'll need this connection object. So to be able to use it in different places in the application, uh, I think the cleanest way to do that will be to like store it in a React context and just inject it to whichever component that needs access to it. So I created a simple context here. It's there are some parts below, but we will cover them in just a moment. I store here the connection object in the use state resist. Use state resist is like it's a library which is like use state, but also store the state in local storage. Because, like as I said, I don't want the user to choose the like connection method each time so he opens the application. So I store the connection method, and here below in the context provider, I provide the connection object and the set connection method to the user. Now, as you can see, there are other three methods. What are these methods, you ask? So basically, like depending on which way the user chose, which method he is using, the actions of signing an event or encrypting message or decrypting message will be a little bit different according to which way. So, for example, sign event, let's see how it is implemented. The sign event function, which takes an unsigned event. If the user is connected using his Nostr extension, then the way to sign an event will be to call the window.nostr.signEvent function and then get the signature property out of that. However, if he chose to use his own private keys, uh, whether inputted or generated, then we want to use the Nostr sign event method, which is a method exported by Nostr tools. And maybe there is another way, which is like, for example, Nostr Connect. If he chose to Nostr Connect, to use the Nostr Connect method, then we will sign it using Nostr Connect object dot sign event. So this if-else logic that you see here, like by default, we will need to do this logic in each place we want to sign an event. In whichever component. But if we don't want to duplicate it like this much and to like just keep copy pasting it everywhere, why don't we like just create a method here in this context that is sign event? It will have this switching and if else statements, whatever, and it will also like just pass them along with the connection and set connection. It will pass these methods to whatever childrens they need to use. So here in the create node component that we created last time, when we want to sign an event, we just like get this sign event from this context and call it. No need to see if we are using window.nostr or if we are using inputted keys or whatever. We just call this method and all of that logic is handled there. This is much cleaner. So, okay, we were here. So yeah, this is a created three method, sign in event, encrypt message, and decrypt message. We will cover the encrypt message and decrypt message once we go to use them. Uh, and one thing cool about this, like this code might seem a little bit complicated, but like it's actually not that complicated. Once you read it, it will be very clean. But the cool thing I think about this code is that you can like I tried to create all this logic in custom hooks and contexts that you can just copy paste and use them in your projects. So like they are very reusable and composable. Okay, uh, this was about how. Let's here. Okay, I'll go with use extension. Confirm. Okay, I logged in using my RB extension. This is my Nostr profile avatar, by the way. And now we have here two pages, the feed page, which we created in the previous part, and the DMs page. Now, the DMs page, as you see, there is already, I built the UI components, but they are not yet connected to the Nostr relays or whatever. We will do that together right now. So for the directing messages, we have two main components. The contacts list, where we can add like some public keys that we want to send message and receive message to and from, and the message container itself. Currently, we don't have any contacts. Let's add one. This is a profile I created on Snort for testing. Okay, as you can see, it added the profile. And here you see the message container. I can type a message here. Of course, now it's not working yet. We will implement that now. So let's go here. Close all of this. Direct messaging. So this is the main component that has the contacts list component and messages container component. The contacts list is this one, as you saw, and it's already built. The message container component is where we will do most of the work. Now this is the messages container component. Uh, Now this component, it will receive the currently chosen public key that we want to view the messages that we have with him and to send receive messages from him. So it receives this as a current open contact, a prop string, and we'll need to do like a few things here. So let's go. The first thing is, of course, we want to query for all the messages that we have with this public key. So let's create a subscription. Consub. It will be very similar to the subscription we created in the previous video, but with like a slightly different filters. So relay bool dot subscribe. The relays are and here are the options. Okay, so just a few things. The relay bool is I get it from this custom hook that I also created. Like uh, it's exactly the same how we created a bool in the previous video. We just using new simple bool, which is exported from the store tools. But instead of like doing this in each component that needs access to the relay bool, which is not like performant at all. Like imagine if we have three components and each one of them needs access to the pool to create a subscription or to publish something, and each one of them recreates a pool and with all of its connection each and every time. This does not really make a lot of sense. So the better way is to create the relay pool once, and just like give access to this single relay pool to all the components. So that's what I'm doing here. I'm creating context where I have a relay pool being stored in a state, and I send it to the children components. Okay. And this relays.getRelays is a simple class where I store all the default relays that I am currently using. And you can, like, if you want to create a UI for the user where he can add more relays or remove some of the existing relays, you can do that, but we currently don't have that. But like just the message is there. Okay, so back here to creating the subscription. Relay pool.sub. The first argument is the relays we want to send the subscription to. The second argument is the filters we want to use on this subscription. So to get all the messages that we have, or all the encrypted messages that we have with a certain public key, we have a few things we need to put in the filter. The first thing, of course, is that it's a kind of for. NIP4. The other thing is now how, like, if we just keep it as a kind for event, then we will get all the encrypted events created by anyone or sent by anyone. But we only want the events that are either created by us, the kind for events that are created by us and sent to someone, or created by someone and sent to us, right? So we need to specify to put our public key uh, and their public key in this filter query. So um, let's handle the first case first, which is that we are the one who sent these messages. So we will use the authors parameter, and on it we will put our mypub key. Mypub key is the pub key extracted from our Nostr connection object. So now we are saying we want all the kinds for event that are created by our public key. But is this enough? Because this way we'll get all the messages that are created by us but that are sent to anyone. However, we only want the events that are created by us and sent to a specific public key. So to do that, we also add the hashtag B filter, and we put the current open contact. When you, like, we will see in a moment that when we want to create a kind for event, we put the hashtag B, we put the public key of the person we are sending the message to. Okay, so right now, and let's just add a limit of 100. Maybe you don't want to put a limit, but like I think putting a limit is better usually. Okay, so right now we are getting all the kind for events that are created by our public key and are sent to the public key of the person who we are currently open the chat for. Okay, so now there are like, this is only one side. We want the other side. We want the messages created by the other person and sent to us. So it's very similar to this filter, only we switch those. My pub key. So the author is the other public key, and the one who is like the messages are sent to is our public key. Okay, this is the subscription. Let's listen to it. Hub.on event. Now create an event handler. Let's extract this event handler into on event. Okay, and pass it here. Okay, so now as you see, we will receive the event. Let's just log this event and see what it looks like. Okay, we'll cover the other steps after that. Let's go back here, open the inspect menu. Okay, we don't see anything because currently, this contact has not sent us any messages, and we did not send him any message. So let's go to this profile and send some messages to here. Here, go to search. Let's put my public key. Message. Say hello integer. Send. Okay. As you can see, the message appeared here, the event. Uh, if you look here, you will see that the content is not hello integer, but instead it's this encrypted text. So we'll need to decrypt this content before showing it here. How can we do that? Let's so on event received, we need to use these things. The first thing, as we said, the decrypting of the event. Const decrypted message. It will be some way of decryption. Now, the way we'll decrypt the text will be different according to how we connected our Nostr key. So let's go to here to the file where we have the Nostr connection. As you saw, we already have a decrypt message method. Now, here, depending on the connection type, we do the decryption differently. So, if the type is using Nostr extension, then we first check to see if the window.nostr object has an IP4, because even if you are using a Nostr extension, the IP4 is an optional method. It's like the required methods are only the sign event and get public key. The IP4 is an optional, so yes, your Nostr extension might not have an IP4. If it exists, then we will call window.nostr.nip4 decrypt method, which takes two arguments. As you see here, the first argument is the public key, the public key of the other person, not us, because it will use our private key, which is stored in the extension, but it also needs the public key of the other person who we either send the message to or receive the message from. And the second parameter is the message. Okay, just a quick thing here. If we check the NIP4 README, you will see that the encryption key is created, or the shared secret is created by a combination of our private key and the other party public key. So when we want to encrypt something or to decrypt something, we always need our private key and their public key. Of course, this is the logic for encrypting something. However, because we are using a Nostr extension, this logic is inside this decrypt method here. We don't need to write it ourselves. Okay, and if we are not using an extension, if we are using generated keys or inputted keys, then we will be using the nip4.decrypt method. Nip4.decrypt is also exported by Nostr tools, so like even without you don't need to write this logic at all. And we send it also the private key, the public key of the other person, and the message. If we are using Nostr Connect, then we also use its method of nip4.decrypt. Okay, back here. So we want to decrypt the message. Let's from user use Nostr connection. We will take the decrypt message method, put it here, and we will send it the event dot content and their public key, which is the current open contact. This returns a promise, so we need to use await here and put async here. Okay, let's log the decrypted message to see if it's being decrypted correctly. Yeah, okay. Hello, TG. Cool. So now we have the decrypted message. We just need to add this message to the UI. We have here a state, list of events. So we will just, after decrypting the message, we'll just say set messages. Okay, if we do it this way, but like it will always append this event to the end of the list. However, we want to put it with taking into account its created at field. Because we might receive events not in their creation order. If we are receiving multiple messages from multiple relays, we might receive some of the older events before some of the newer ones. So we will use a method that we used in the previous video also, which is insert event into ascending list. We give it the messages, the sorted messages, and the new event that we want to insert. This method basically uses the binary search algorithm to find the right place to put this event object in and returns the new sorted list. Okay, let's save. Missing clips hotels. Seems we have an error here. Oh, sorry, I imported it from the wrong path. Mm, I'll just, I think, copy it from here, the path. Okay. So, put it here, put it here. Okay, let's see. Oh, it's now it's just like appending the message, but it's yeah, we did not use the decrypted message field. So just do that here. Content, that will be the decrypted message. Refresh. Oops. Ah, okay. Actually, I wanted this to work first, but we will come back to the error again. As you can see, now it's working. It's showing the decrypted message. Let's send another message from here. How are you? Send. And as you saw, it appears immediately here. Now, there is a problem. Like maybe you can already see in the console that we have an error message saying Nostr call already executing, right? So what does this mean? So this error message means that, like here in the code, the interval of which we receive the events is much more quicker usually than how quickly the decrypt message method is being executed. So we are maybe receiving 10 messages in, for example, 10 milliseconds, and each event is trying to call window.nostr.nib4.decrypt. But when the first event calls this method and it starts decrypting it, the second event is being, like, after it's received, it tries also to call this method before the first event finishes decrypting itself. So it cannot do that. Now, I'm not sure if this is a limitation from Albi specifically, that it cannot uh, do multiple calls to Nostr in parallel, or if it is something like with extensions in general. Uh, but we need to solve that. And the way to solve that is to make sure that events are being decrypted one after another. So an event will not try to call the decrypt method unless the event before it has finished decrypting. So how can we do that? Actually, it's not complicated. I created here a simple class called Decryption queue. Uh, like simply I just store a list which is a queue of events. Each time I want to decrypt something, I uh, I add the encrypted message here and the public key that will be used with it, and the success callback, which will be called with the decrypted message when it's done. Uh, After it's called, it will be added to the queue. And the queue like has a simple way of, like, it uses a flag which is decrypting. Uh, if it's false, it starts the decryption. If it's true, it will store it, keep it in the list until the current event finish decrypting. Here is the decryption method. It just like takes the first item in the queue. It will call the decrypt function. If everything goes alright, it will call the success callback, and it will, if there are still events in the queue, it will try to decrypt them. If it's not, it will stop. So, and all the methods are static. This class uses the singleton pattern, which means that it will, like, only a single instance of this class will be available globally. So if you have, like, basically if you have multiple components and all of them are using the decrypt method, you don't need to find a way to orchestrate the queue between all of them. You have a single global queue, and all of them are sending and receiving events from this queue. So back here, instead of decrypting the message immediately, what we want to do is we want to say decryption queue dot add. Now the add method, for the first argument, it takes the content that we want to decrypt, the public key, which is the current public key, and the callback. The callback will be actually just responsible to do the same of what we are doing here. Decrypted message, set message. Oh, sorry, this is error. The first argument will be error if there is any. The second argument will be the decrypted message. So here we can just, like, do a quick check if an error happened. For example, the user rejected decrypting the message, because when you make the decrypt call the first time, the extension will show a pop-up asking the user to confirm whether or not he agrees to decrypting a message. So he might reject this prompt. So if there is an error, we can just quickly say error decrypting message. or user rejected operation. If it's not, then we will do this. Okay, and we can remove all of this, I think. Yes, yes. Okay, let's say here, back, refresh. Okay, as you can see, the Nostr already called error is not appearing anymore. Okay, and now, if you remember, just previously the application crashed. It was due to the same error. So now everything should be working greatly. The last part we want to add is how to create our own messages and then send them to the user. Currently we only receive messages, but we don't send messages. So let's do that here. Now here, this is a simple input form. When the user creates something and clicks the send message button, it will take him to this send message method. Now we need to do two things. The first one is creating the event. The second one is publishing the event. Now publishing the event is not something complicated. We did that in the previous video. So this is the code for it. The new thing is creating the event with the encrypted content. So let's first create the event. Okay, so just a reminder, the event, the fields that are in the event, okay, they are not appearing here, but the basic fields that we can fill right now are host. Let's call it base event, for example. Okay, it needs a kind, which is for as unsigned event, so that it's typed. Okay, the created at, it will be math.round date.now divided by 1000 because it's not in millisecond but in seconds, and we need the public key, or like the author, which is my public key. Tags, the tags, it will be a list of tags we want. Maybe you want to add some additional stuff, but you need to at least put one tag, which is a b tag, that contains the value will be the public key of the of the person you are sending this message to. So it's current open contact. And finally, we need the content. Now the content, if you just put message input, this is the not encrypted content. We want to encrypt it before we put it in the event. So to do that, yes, we have another method here, which is encrypt message. If you want to see its code, then it's not complicated really. It just takes the message that you want to encrypt and the public key of the other party. If you are connected using Nostr extension, it will call like window.nostr.nib4.encrypt. If you are using generated keys or inputted keys, then it will call nib4.encrypt, which is, like as we said, exported from Nostr tools. If you are using Nostr Connect, then it will call the nib4.encrypt method that exists on the Nostr Connect instance. Okay, so let's use this method down here. Content, it will be encrypted message dot the message, it will be the message input, the public key, their current public key. Okay, it returns a promise of a string, so we need to do that here. Encrypted message, yes, like this, and we put it here. Now this base event, the only things that is missing is signing the event and the ID. So let's first create the ID. Actually, we can do both of them at the same step. We have event here, so it will be base event. The signature will be sign event. Let's also, we have the sign event here method. So sign event, and finally we need the ID, which is get event hash. This is a method exported by Nostr tools. You give it the event and it will create the ID of it. Okay, now we have the event that we want to publish. We are publishing it to the relays. Let's just log it here to see it and return before publishing it to see if it's working correctly. Let's type something. Hello, Sally. Send. Okay, as you can see, um, the I'll be show a pop-up asking us whether we want to encrypt the data. Confirm. Now it's showing us another pop-up because it wants to sign the message, which is something different. Confirm. Okay. So now you see here the event. It has encrypted content, and the tags looks okay. Okay. Everything looks good. So let's remove this console and let's just remove this console log here, by the way. Okay, so now let's try publishing it. Hello Sally, send, confirm, confirm. Okay, it's here, and you can also see it here in Start. Okay, how cool is that? Are you? Let's try sending another message. Not good. Encrypt, encrypt, and you see it immediately. Okay, I think everything is working now. Let's close this. Okay, great. So now we have encrypted direct messaging working with Nostr. Now, one thing worth noting is that you might send some messages, but you might not see them on the other client. So just make sure that you have a couple of relays in common. You are using like the same, for example, demos relay here and demos relay there. And yes, I think that's it. The code will be available on GitHub. The code before we added the Nostr stuff and the code after we added it. And if you have any questions, feel free to send them to me on Discord. And I'll try to reply them as soon as possible. And yes, that's everything. Thank you for watching and have a nice day. Goodbye.